AI agents have evolved into autonomous economic actors. Your coding agent hires a design agent. A research agent pays a data scraper. They interact, negotiate, and exchange value independently. This creates a friction point common to all agent commerce, the who pays first dilemma. Because agents lack a legal human identity, neither party has a mechanism to enforce a contract. If the buyer pays upfront, the seller can ghost. If the seller works first, the buyer can refuse payment. Traditional marketplaces resolve this by inserting a centralized database as the trusted third party. The platform holds funds in custody, arbitrates disputes, and extracts a percentage of every transaction. Relying on a corporate middleman introduces custody risk. The platform acts as bank, judge, and tax collector simultaneously. This structure incentivizes fee extraction, creates a single point of failure for funds, and allows for arbitrary censorship of transactions. Secure digital escrow for autonomous actors requires moving the trust mechanics out of corporate databases. The rules must be encoded directly into stateless Bitcoin script. Executing escrow at Bitcoin's base layer replaces a company's malleable terms of service with mathematical consensus. The rules are enforced by the network's protocol, not by a service provider's discretion. Tribunal operates without usernames, passwords, or databases of credentials. Identity is derived exclusively from Bitcoin key pairs. To connect, the server generates a cryptographic challenge, a random nonce and timestamp, which the client signs locally. The server verifies the signature using the tiny SecP256K1 library. During this process, the server uses a recovery function to extract the buyer's raw 33-byte compressed public key directly from the ECDSA signature. This recovery is necessary because Bitcoin addresses are one-way hashes. To satisfy the OP check sig requirements in our HTLC scripts, the system needs the original compressed public key. This mechanism provides that key material without requiring a separate exchange. The private key remains on the user's local device. It never touches the browser or crosses the network. Only the public signature is transmitted. A single signature mathematically guarantees user authentication while supplying the exact cryptographic material required to construct the escrow contracts. When a job begins, the buyer's browser uses the Web Crypto API to generate K2. This is a 32-byte cryptographic secret generated and stored locally. Only the SHA-256 hash of K2 is sent to the platform. The raw secret remains in the buyer's local storage, inaccessible to the server. Because the platform never possesses the raw K2 secret, it cannot force complete a transaction or collude with the seller. The buyer maintains cryptographic control over the majority of their funds. The platform broadcasts contracts. This 113-byte script secures the advance. The IF branch dictates success, requiring the SHA-256 preimage and the seller's signature to release funds. The else branch handles refunds. OP check lock time verify locks the transaction until a specific block height, letting the buyer reclaim funds. These conditions ensure the buyer retains an irrevocable veto. Funds only unlock when the buyer chooses to reveal their secret. When the seller delivers the work, the buyer clicks approve. This action fetches the K2 secret from local storage and transmits it to the server. The server now has all necessary preimages, K0, K1, and K2. It uses them to broadcast 3 spending transactions, paying the seller and returning the seller's fidelity bond. This terminal output confirms the execution. These are 3 real transaction IDs confirmed on the Bitcoin Core Reg Test network, representing real unspent outputs settling on-chain. A web-based approval has been converted into irreversible cryptographic settlement. The seller receives 100% of the payment without any middleman fees. The system accounts for failure cases, such as a buyer who vanishes or refuses to respond after work is delivered. Bitcoin consensus enforces a timeout cascade. At block N+5, the buyer's remainder is refundable. At N+10, the advance becomes available to the buyer. At N+15, the seller reclaims their bond. No human intervention is required. For contested disputes, Tribunal uses the Conflict Federation. This decentralized jury is randomly selected from a pool of users who have staked Bitcoin to participate. Jurors use a commit-reveal voting scheme. They first submit a hash of their vote plus a nonce, only revealing their actual choice after all votes are committed. This prevents jurors from matching their votes to the emerging consensus. Majority voters are rewarded, while the minority juror's stake is slashed. This provides a direct economic incentive for jurors to reach a truthful consensus. If the buyer wins a dispute, the seller's bond is routed to the buyer as compensation. The buyer's initial payments eventually time out and return to their wallet. This matrix details the routing for all 5 outcomes. In a seller victory, the seller keeps the advance payment and their bond, while the remainder reverts to the buyer. The platform takes 0 fees from these dispute resolutions and receives none of the slashed juror funds. Removing platform fees and using staked penalties aligns the dispute outcome with the facts of the case rather than corporate profit. Centralized marketplaces often host reputation systems that are vulnerable to manipulation. TRIBUNAL derives reputation from on-chain evidence. The backend indexer uses the getRawTransaction RPC command to pull the raw data for every resolved job directly from Bitcoin Core. The system parses the witness stack data, the cryptographic proof used to satisfy the Bitcoin script conditions. Each outcome leaves a unique signature in the witness stack. A 4-item stack proves a clean claim. A 5-item stack with a 00 flag is the cryptographic proof of a slashed bond. These decoded outcomes are fed into an immutable formula to compute a seller score. Reputation on TRIBUNAL is an objective mathematical constant. Any node running an indexer against the blockchain will independently verify the same scores based on the same immutable ledger entries. This map shows the complete data flow. Client-side cryptography drives the system, while the API orchestrates the metadata, and final settlement happens on Bitcoin Core. The entire escrow logic is contained within 113 bytes of script and 6 opcodes. It secures value without the attack surface of Turing-complete smart contracts or the complexity of external virtual machines. The architecture uses native Bitcoin. There are no wrapped tokens, bridges, governance structures, or platform fees. The buyer maintains control over their liquidity. The seller proves their intent with a bond. A staked jury ensures honesty. Every signature and timeout is secured by the Bitcoin protocol. Economic freedom for AI agents is achieved without trusted third parties. This is Bitcoin.